All right, in this video, I'm going to go over how to take the derivative of a quotient. And what we're going to do is we're going to use the quotient rule. So the quotient rule states that if we want the derivative of f of x divided by g of x, it's equal to g of x times f prime x minus f of x times g prime x divided by the quantity g of x squared. Well, a good way to remember the quotient rule is looking at the f of x and g of x as a low and a high function. Okay, so if we consider f of x as the high function, meaning it's up top, and g of x as the low function, we can use this saying here, low d high minus high d low divided by low squared. So this was something that I would teach to my students. It's pretty common. And it's an easy way to remember the quotient rule. All right, so let's try some problems with the quotient rule. All right, so the first problem is we have y equals x cubed plus 2x squared minus 1 divided by x plus 5, and we want to find y prime. Okay, so we're trying to find y prime here. So the first thing I'm going to do is we want to identify that my x plus 5 is going to be the low function, and my x cubed plus 2x squared minus 1 is going to be my high function. Okay. Now when I say d high and d low, that means we're taking the derivative of those functions, the high or the low. All right, so it starts out, it says low d high, so low times d high. Well, d high is going to be the derivative of x cubed plus 2x squared minus 1. So that's going to be 3x squared plus 4x. Okay? Minus high. So the high function is x cubed plus 2x squared minus 1 times d low. Well, the derivative of the low function is 1, so we just have times 1, so I'm not going to write anything there. All divided by low squared. So we have the lower function x plus 5 squared. Okay, so now what you want to do is you want to simplify the numerator. All right, so it looks like we're going to have to distribute the x plus 5. So we would get 3x cubed plus 4x squared plus 15x squared plus 20x. I'm going to distribute the negative 1 minus x cubed minus 2x squared minus 1, all divided by the low squared. All right, so up top, I'm going to combine the like terms in the numerator. So it looks like I have a 3x cubed and a minus 1x cubed. So that would be 2x cubed. It looks like I have a 4x squared, a 15x squared, which is 19x squared minus 2x squared, which would be 17x squared. And then I have a plus 20x, and then I have a plus 1, all divided by x plus 5 squared. All right, so there's our first example with the quotient rule. Okay, in our next example, let's let g of x equal x squared plus 7 divided by 2x minus 7, and let's find g prime of x. All right, so same thing, we're going to go low d high. So low is 2x minus 7 times d high, which would be 2x, minus high, which is x squared plus 7 times d low, which is 2, divided by my low squared, so 2x minus 7 squared. All right, so in this case here, we're going to distribute the 2x. So I would get 4x squared minus 14x. And then I'm going to distribute the 2, and then I have a minus out front. So this would be negative 2x squared minus 14, all divided by 2x minus 7 squared. So I would get 2x squared minus 14x minus 14 divided by 2x minus 7 squared as my answer. Okay, in our next example, we're going to let h of x is equal to cosine x divided by x for x not equal to 0, and we want to find h prime. Okay, so we're going to use the quotient rule. So we got low times d high. The derivative of cosine is negative sine x minus high, which is cosine x, times d low. The derivative of x is 1 divided by low squared. So this would simplify to negative x sine x minus cosine x, all divided by x squared. All right, so let's let f of x equal x plus 1 divided by x minus 1 for x not equal to 1. Let's find f prime here. All right, so we're going to go low times d high, derivative of x plus 1 is 1, minus high times d low, which is 1, all divided by low squared, x minus 1 squared. So we simplify the numerator, so we're going to distribute the negative 1 over x minus 1 squared. So this would equal, the x's are going to cancel, so we would get negative 2 divided by x minus 1 squared for f prime. Okay, in our last example, we're going to give some equations here that may look like the quotient rule, but you don't always have to use the quotient rule. So the quotient rule would be the last resort if you can't do it in an easier way. So in each of the three equations I have here, I can do these without using the quotient rule. So in the first one here, we can rewrite this as 7/3 x to the negative third power, and then we can easily use the power rule, and we would get negative 7x to the negative 4 as the derivative. Okay, so that's one example. The next one, again, looks like it is a quotient, but can we rewrite this so we don't have to use the quotient rule? Yeah, so we can write this as 4x, and by the law of exponents, this would be x to the half. So y prime would be 2x to the negative a half. And same thing with this last one. We can easily rewrite this as 1/3 x squared plus 2/3 x because they have the common denominator. So y prime would be 2/3 x plus 2/3. Okay. Well, I try to give you some good examples using the quotient rule. I hope you liked the video, so please like and subscribe. Thanks for watching.